Welcome student. Today I am going to explain you one of the very important concept of the chemistry, that is laws of chemical combination. It will form the fundamental of all the reactions which you will be going to study in future. So what comes under the law of chemical combination? The very first law is a law of conservation of mass. The second is law of definite proportion. The third is a law of multiple proportion, and fourth one is law of reciprocal proportion. So one by one, I'm going to explain you each and every law with suitable example. The first law is law of conservation of mass. So what does this law states? Mass is neither created nor destroyed in the chemical reaction. So what does it mean? It can be explained with a simple example as the formation of water molecule. So when we say there is a formation of water molecule, it takes place by the reaction of hydrogen molecule with the oxygen. So in balance form, we can say 2H2 reacts with O2, giving you 2H2O. So when I say that 2H2, so mass corresponds to 2H2 is a 4 gram. So 4 gram of the hydrogen reacts with the 32 gram of the oxygen, giving you 36 gram of the water molecule. So it is a standard condition as per law of conservation of mass, that mass is neither created nor destroyed. So if you see 4 gram plus 32 gram giving you 36 gram. So there is no loss of the mass anywhere. So considering this as a representative example, if I ask that what will be the amount of H2 as a mass of H2 reacting with 16 gram of O2 giving you 18 gram of water. So you can guess the simple answer will be a 2 gram. Similarly, if I say that there is a reaction of 1.5 gram of the hydrogen with certain amount of oxygen giving you 27 gram of water. So by using law of conservation of mass, you can say that the amount of oxygen will come as 25.5 gram. So I hope that all of you are getting what this law means and how it is important. Next to that is a law of definite proportion. So what does this law states? The statement of this law is different sample of the pure chemical substance always contain the same proportion of element by mass. So I have highlighted few words, that is different sample, and again a word as a pure. So whatever samples you are collecting, they should be from different origin and they should be a pure sample. So when you compare such samples, so if I say that I'm having a water sample which is collected from different sources, so all those water sample will always contain 2 gram of hydrogen and 16 gram of oxygen, provided that they are in water is in a pure state, irrespective of the source from where it is collected. Always it will have 1 is to 8 as a their mass ratio of hydrogen to the oxygen. Similarly, if I say I'm having a sample of carbon dioxide, so that sample from whatever reaction it has generated or from whatever source I collected, it will always contain 12 gram of carbon and 32 gram of the oxygen. So the ratio will come as 1 is to 2.67 by mass. So this is what law of definite proportion means. The third is a law of multiple proportion. It is one of the very important law in the chemistry. What does this law says? If two elements combine in different ways to form different substances, so elements are constant but they are forming different substances. The mass ratio are small, whole number multiple of each other. This can be explained by taking an example of oxides of the nitrogen. So here is an example. So if I say that nitrogen is forming different oxides as N2O, NO, N2O3, N2O4 and N2O5. So in all these oxide, there is a fixed amount of nitrogen and there is a fixed amount of the oxygen. So if I calculate the mass in all the oxide, you will get in first case mass as a 28 of the nitrogen. In second case it is 14. In third, fourth and fifth case, the mass of nitrogen is 28, 28 and 28. If I calculate the mass of oxygen in all these oxides, in first and second oxide, it will come as a 16. In third, it will come as a 48. In fourth, it will come as a 16 into 4, that is 64. And in fifth, it will come 16 into 5, that is 80. So in this way, you can calculate the mass of oxygen. Now, as per that law, if I make one of these as a fix, so if I consider that I'm going to treat nitrogen as a fix, and if I make in all case nitrogen as a 14, 14, 14, and 14, so accordingly in a proportion, the oxygen will decrease. So if I say 14 gram of nitrogen is there in first case, so oxygen will come as a 8 to keep this ratio constant. That 28 is to 16 will be same as a 14 is to 8. So similar treatment if I do for 14 and 16 as a NO, so it will remain as a 14 and 18 only. Here it is 28, 48. If I make this as a 14, this will come obviously one third of, you can say half of it, so it will come as a 24. If I make it as a 14, so it will come as a half, it will become 32. If I make it 14, it will come as a 40, so it will come as a 14 is to 40. So as per the law of multiple proportion, if I keep one thing as a constant, the other part of it will always be having a simple whole number ratio. So here this whole number ratio will come as 1 is to 2 is to 3 is to 4 is to 5. So if I keep nitrogen as a constant, so the variable amount of oxygen which combined with the fixed amount of nitrogen comes in a ratio as a 1 is to 2 is to 3 is to 4 is to 5. So this is what law of multiple proportion says. So in an exam you may get some different example, for example like PCl3, PCl5, in which phosphorus is constant but the amount of chlorine changes. So if I take the ratio of the chlorine as a Cl2 and chlorine as a Cl5, the ratio will come as a, if I consider exact mass of it, so it will come obviously 35.5 ka ratio if we take as a 35.5 into 3 in case number 1 and 35.5 into 5 in case number 2 of PCl3 and PCl5 respectively, the ratio will come as a 3 to 5. So I will be covering that example in our next presentation. Next is law of reciprocal proportion. This is again one of the very important law. So what this law states, if certain masses of two different element A and B combine separately with the fixed mass of another element C. So to give an example of A, B and C, I can say that if I am considering carbon as a, hydrogen as a B, so if I say carbon and hydrogen are combining with each other forming methane, the ratio of their masses will come as a 12 is to 4, as a simple ratio 3 is to 1. Now if I consider the second case, keeping this B as a constant over here and combining with the third element as a oxygen, so they will come, hydrogen will combine with oxygen will give you H2O. So the ratio of hydrogen and oxygen in H2O will come as a 2 is to 16 and simple whole number ratio as a 1 is to 8. So for me, if this is A, this is B, so here again it will come as a B and this will come as a C. So this A can combine with C in a same ratio as 3 is to, you can say 8, as it is combining in a methane and in case of water. So this is a meaning of law of reciprocal proportion. So the same law can be explained by taking an example as a reaction of hydrogen and sulfur giving you H2S. The ratio come as a 2 is to 32. Simple whole number ratio come as a 1 is to 16. And if I say hydrogen is combining with oxygen, so ratio will come again as a 2 is to 16. Simple whole number ratio come as a 1 is to 8. So here if I keep hydrogen as a constant and if I make sulfur reacting with oxygen giving you sulfur dioxide, the ratio may come as a simple whole number ratio as a previous, or it may be either 1 as it is written either 1. So ratio may come as a 1 is to 1. So this is a meaning of law of reciprocal proportion. So hope student that you got all these four laws of chemical combination. In the next lecture, I will be coming up with certain examples which have been asked in previous NEET or JEE paper, or the examples which are given in various books or various sites for the competitive exam.